So we're project number 10, Covididentify. I'm Emmanuel Mokel, and my team members are Sean Fiscus, Alyssa Shee, and Yamil Lopez Ruiz. For a basic overview of our project, Covididentify is an ongoing study at Duke University, which uses data coming from wearables to predict and diagnose whether or not somebody has COVID or other similar influenza-like illnesses. There's a lot of signs and symptoms that one doesn't immediately notice that these devices can pick up, which can help you realize whether or not somebody has COVID before they start showing symptoms. And it builds off of work previously done by the Capstone project for the Masters in Interdisciplinary Data Science, or MIDS team. And our project manager is Peter Cho, and we're led by Dr. Jesselyn Dunn, who leads the Big Ideas Lab in the Biomedical Engineering Department. For our basic project objectives, we sought to improve the memory usage of the existing pipeline that was developed by the MIDS team, to adapt the pipeline and make more efficient methods with it, to implement all of our data sources for pre-processing, and to assess the user adherence for the smartwatch data. And we have over here in the objective session kind of like a basic workflow of what we're doing. So we start out an initial SQL database. We push that onto a Python script where we start to transform and normalize the data. It's moved into some sort of tabular format, and then it's eventually moved into Microsoft Azure blob storage. And it finally ends up in a final SQL database where researchers can start to perform analysis on it.
So over the course of the project, we mainly worked within Microsoft Azure Machine Learning, or Azure ML, which is a cloud-based computing service, which is where we did the majority of data extraction, transformation, and loading, or ETL. And this is all within Microsoft ML. In addition, we used Azure Data Studio, which housed the SQL databases where our data was stored both before and after processing.
So looking into the memory efficiency, so the problem that we found with memory efficiency was that after data was read into Python from the initial SQL database, it was being appended to a quickly growing pandas data frame at two different locations in the pipeline. The team decided to use Azure Cloud Services to avoid the large RAM storage. The solution we came up with was split into two parts. First, we implemented batch pulling methods to pull from the database. We then added row-by-row normalization and an exportation process. So with the pipeline simplification, the problem we found with the multi-step pipeline was that there were redundant data transfers and storage, which made the data upload speed slower, causing new implementations for improving memory efficiency to have lower data upload speeds. We did research into different data file types to see which would have a quicker upload time and decided to test out pickle files. We later began to create Python scripts to write directly to the SQL database after normalization, which allowed us to cut out the need for CSV/pickle files. This is shown in the image below, where we can see that some intermediate steps have been taken out compared to the initial image that we saw in the objective section. In the line plot here, we compare the runtimes for different pipeline methods. We compare the original method to the updated CSV, pickle, and finally the SQL method. We can see that the pickle files were the quickest, but due to some inconvenience, we decided not to go with this choice. We see that the CSV method did increase the time, so the final SQL method was the most convenient as it had a similar time to the original method while also cutting out steps in the pipeline.
So yeah, for the next stage in our project, we actually looked into expanding the pipeline to be able to accommodate for more data types that were in the initial SQL database but hadn't been implemented into the full pipeline. And the one we focused on with this was Fitbit data coming in from users who have Fitbit smartwatches that came in after they had signed up. And after they signed up, the data comes in minute by minute, so it's much higher density. And so data was coming in minute by minute for heart rate, steps, and sleep data. So we implemented this into the pipeline. And then finally, for the fourth step in our results page, we had successfully found a way to efficiently implement data types through the pipeline. And so now it was sitting in our final database, and we started the initial data analysis of that final database. The step we started with was looking at users' adherence, or how often they were kind of recording data or wearing their smartwatch basically each day and then across days. So with these two different measurements, like per day and across days, we were able to subset the data by thresholds of 2, 4, 6, and 8 hours of users wearing their watch per day. And then in the graph here, you can see that for 5 different participants, the number of days that they have data that exceeds the threshold per day starts to drop off as you increase that threshold from 2 to 4 to 6 to 8 hours in that graph.
So in conclusion, some of our key accomplishments included reducing the memory usage of the extract, transform, and load, or ETL data pipeline, expanding the type and resolution of the data that was in storage, and creating a foundation for future wearable data processing for the Big Ideas Lab, not only within this project, but for any project that uses wearables data. In terms of next steps, we need to integrate iOS or Apple Watch data and continue to analyze and apply machine learning algorithms to our data. Thank you for listening and feel free to ask us any questions.
So thanks all. That was very nice presentations and really good work this summer. Folks, just go ahead and unmute yourself or put questions in the chat, whatever is most comfortable for you.
I just want to add, if you want to take a closer look at some of these graphs, which show up pretty small on this screen, we have some slides after this slide that kind of expand those graphs.
Awesome. Yeah, it's throwing it open for open questions.
You could show some of the expanded slides, maybe.
Yeah, that'd be a good idea.
So yeah, this is the graph that Yamil talked about.
Could you maybe explain the difference between the full pipeline versus just the load?
Yeah, I can take that. So yeah, the SQL full pipeline, which you see plotted in green here, was the final implemented pipeline that we looked into doing. And that actually includes data coming in from the SQL database, going into the Python scripts, and then writing from the Python scripts directly to the final SQL database. And so we were able to actually log that entire time because it's all basically done in the Python scripts. So we were able to use like code in the Python to track whenever it's starting and ending. All of the other plots here actually only include the first steps of the pipeline where it's coming in from the initial database and then being pushed to either a CSV or a pickle file and being stored temporarily. But it's the time logged is actually not including moving that data from a CSV or a pickle to the SQL database. So the fact that this green line here is like equatable to the original model is actually very good because it's including more steps in the pipeline than the original model is. I know that might be kind of confusing because it's showing a little bit different things on the same graph, but yeah.
Yeah, kind of what Sean was saying. This is when we realized, if you look at this and you look at also the figure with kind of like our workflow, this is where we realized we could really cut steps out. Because, you know, for example, when we were working with, right here, when we were working with Pickle, we realized, as you can see the other graph, like Pickle works very quickly, but we would take the original Python. Yeah, Pickle was the fastest time here. But what would happen is we would take we would get the data in a tabular format, we would transform it to Pickle, and then we'd end up pushing it to Microsoft Blob Storage, eventually put it in the SQL database. And we kind of realized, you know, we were going to pickle the data just to immediately unpickle it, or we're going to push it to the SQL database in a pickle format. And what pickle is a serialization method, and it's written in binary. So it's not really in a format in the database where users or researchers can look at it and really understand what it's doing. So we started to realize then, rather than changing it to a CSV or a pickle or certain type, we also researched Parquet, HDF5, and some other ways. Rather than transforming it to a different file format, putting it in blob storage and putting it in the SQL database, why don't we just try to write the data directly into as we normalized, we took our original data, we turned each row into a pandas data frame and used the JSON normalize function on it. And we realized we can probably just write it directly into the SQL database right there. And that cut out about 2 steps.
I'm going to go to the next slide because someone asked for that.
I actually did have a question about this graph. So specifically for participant 5, does that mean that all of their activities were above the threshold? Is that why it's kind of like a level graph right there?
Right. Yeah. So this, like at first glance, if we had just done the 2-hour threshold, it might have looked like this user didn't have that much data because they only had 18 days. That's what that equates to. It's kind of hard to tell on this graph, but they only had 18 days of data above the 2-hour threshold. But this user might actually be beneficial because they were wearing their watch pretty consistently throughout the day, as we can see from the data. So they actually have 18 days of data that exceeds 8 hours. So that might be useful for analysis. Does that answer your question?
Yeah, thanks.
Another thing to note here is like the fourth participant didn't have any data that exceeded 6 hours. So it kind of drops off pretty quickly there.
Well, I'm kind of a bringer here a little bit because they already know that I want to know the answer to this question anyway. But how was Azure, and how were your experiences with it? I assume this is probably one of your first times doing something exclusively with the cloud.
Yeah. Does someone else want to take that question?
Yeah, for me personally, working with Azure had like a pretty big learning curve. And I think in the beginning, we kind of were trying to work in VS Code, and we ran into a lot of issues with that because I think the previous MIDS team had worked exclusively in Azure in the notebooks, and transferring that to VS Code, they were just like, the code wouldn't run, or we would just run into like a bunch of random errors. And so I definitely think that there was a learning curve with Azure, but obviously, like our main focus in this project was data engineering and working on the pipeline, whereas we know that the purpose of Azure ML is that it's really user-friendly for like actually running the machine learning algorithms. So like, I guess we didn't realize that benefit because we didn't actually run any of the algorithms or train any models. But so it was like different for us because all we were doing was engineering. But yeah, for me, there was a learning curve. I don't know if anyone else wants to chip in.
Yeah, I definitely have to agree with us about the learning curve. There were definitely some benefits to Azure, like for example, when it comes to the version control aspect. So Azure automatically saves and like updates your code. So you know, in my previous experiences, when you're doing programming with several people, and you know, one person might be working in like the same location, a lot of times you can run into issues with like merge conflicts and things like that when using GitHub and GitLab. And the way Azure kind of automatically updated, it was a lot of time we didn't really have to worry about kind of losing code, but then it also did make it a little bit fickle to figure out how to properly connect Azure to GitLab. But yeah, it was definitely a steep learning curve in the beginning, but after we kind of got over the initial VS Code hurdle and we kind of started working primarily within the Azure notebooks, it was definitely, I think, a better experience. One of the things we had was like the different access to different sized compute instances in Microsoft Azure. So in the beginning, we were running into some memory issues. So for example, we were able to like make the just make the compute instance we were using at the time larger. And you know, being able to do that also kind of made us realize like where some parts of our data might have been lacking, where we were some areas where our code was very memory intensive. And if we had to use the largest like compute size available, maybe we can start looking at that area of the code and realize, okay, we need to take a different approach so this doesn't automatically use up all our memory while we're trying to run this script.
Yeah, I was just gonna add something kind of interesting that I was thinking about. Like basically with the pipeline simplification that we had talked about, we pretty much cut out like a lot of the steps that Azure was good at doing, because Azure kind of has an umbrella of different like capabilities with like blob storage, and as well as like the pipeline techniques that they have in Azure Data Factory. I don't know if you're familiar with that. But there's kind of a bunch of different packages under the same umbrella. So it's very easy to go from one whatever file format or stage in a pipeline to another stage in a pipeline. But whenever we cut out the need for Azure blob storage to simplify the model, we basically kind of cut out the use for using Azure in this particular case, because we go from a SQL database with a Python script directly to another SQL database. And technically that SQL database could be, I mean, that Python script could be just running on any kind of web service, like as long as it can transfer the data from one SQL database to another. But yeah, I think there were a lot of, like, the hardest thing about Azure was the fact that there's like so many different whatever it's called, like packages. And so when we were first trying to understand how the pipeline was working, finding out where those packages were and where like the data is going from one step to another and then finally to another was definitely the hardest part.
Other questions?
Hi, this is Joe. I was actually with the MIDS team. I guess I wanted to know, when you guys were kind of starting this project, where were some of the pain points of kind of like understanding the problem generally, just for my future turnovers?
Anyone want that one to start? I'm thinking of some things, but
I mean, I was gonna say, I think it's generally kind of hard to, it's always hard to start a new project in general where you don't really have much background. I think one thing for us was there were like a lot of different folders, a lot of different users with like the code in a couple of different places. So I remember we had like a main folder called like Covididentify, but then there was also, there were essentially like kind of two locations that had like essentially pretty much the same scripts. That was a bit confusing in the beginning. Kind of working through one of the main Python scripts that we were really working with was an updated version where you can normalize a JSON, and we were kind of editing that and kind of just understanding, you know, what each step was meant to do, because at some points maybe the README file wasn't as comprehensive, or maybe like I remember at some point one of the parameters of that function was called pipeline, and it had like a yes or no parameter, but in the initial part, I think the comment hadn't been finished at that time. So like kind of understanding, you know, what that parameter was really meant to do and how it was changing what we were doing.
Yeah, sorry
Was a
about
bit,
that. That was my fault.
yeah, it's no problem. I think it was, but I think a lot of it's just kind of starting a new project in general, getting used to looking through the code at each point, kind of understanding like different points of the process. And I think that on top of getting used to Azure kind of made the first 3 weeks was a lot of us kind of reading literature, trying to understand like, you know, the scope of wearables data and what you can do with it, what key parts you might want to understand, and then getting used to Azure and the different software they meant to use, and kind of trying to understand all the past work that had been done. Yeah, Sean, you want to say more?
yeah, I was just gonna say, like, overall, I thought it was pretty well documented in a lot, because for how kind of complex the process of this pipeline is, each step was pretty well documented. So that, like, I was grateful for that, Joe. One of the things I was thinking about, maybe that was the hardest to try to figure out without like specific info, was what was going on in Azure Data Factory, where once the data was uploaded to blob storage in the initial pipeline, how kind of that code, like, or Azure has a lot of like GUI usage, and like instead of actually using any kind of script. And so how these different pipeline triggers and pipeline data transfers were being run inside of Azure Data Factory was a bit hard to figure out. That might have been able to have some more like info on like a README or something like that. But besides,
I agree. Yeah.
Yeah.
To be honest, that was someone else's, another member on the team, and so that was like her portion of the project. Pretty much, the scripts was like for me to get from point A to point B, and then hand it over to her.
And with that kind of part of, I guess, her project, it was probably pretty difficult to document, because it's not like you can just comment code, because a lot of it was like I said, like within the package, different GUIs and stuff like that inside of Azure. So I remember there were some screenshots, but it was still kind of hard to follow. But yeah, I appreciate the work that you did to like have this transfer go pretty smoothly.
Yeah, I thought one of the most helpful things was like using the demos for like Azure Normalizer and like the query transform upload. But I think one of the things that we ran into issues with was I think it could be like a little more detailed, because I think at one point we were trying to run something with like the pipeline code where like the pipeline just hadn't been implemented for it, and we just didn't realize like that's why it wasn't working. And also like I mentioned earlier, like with the VS Code, I think we were trying to do a lot of stuff in VS Code when we should have probably just stuck with the notebook, because when it didn't work in VS Code once like everything was like there.
Awesome. Yeah. Thanks for that feedback, guys.
Other questions? So I guess you all have talked a little bit about Azure and other things, but just I've asked every group this question. Like, anyone want to share anything about sort of their personal kind of journey through this? Like, what did you start knowing? Like, how'd you learn things? What was hard? What was easy? Just generally, you know, practice for the interview question you get when you interview for data science jobs and they ask you to describe like how you got to learn something.
Thinking about this question. I'd definitely say, kind of going off of maybe our last conversation with Joe, the hardest part about projects like these, this doesn't really have to do much with like my journey through the project, but just a difficult thing that I need to, I guess I have improved throughout this project, I'd say, but is kind of making sure everything that you're doing, especially when you're in a project like this where you're working for a short period of time, but you're gonna have to pass on the work to someone else, making sure all of the work that you're doing as you go is being documented very well, so that anyone else can understand the changes that you're making and what you want other people to do with those changes. I think I started out this project for the first probably 4 or 5 weeks. I guess partly because it was just a lot of figuring stuff out, and I didn't know what I was doing. And so it was like, if I don't know, I guess I felt like I didn't really have to document things that I was figuring out, because I was just kind of playing around with things and seeing what works. But after that period of time, I realized a lot of those changes were changes that would help in the long term. And then I had to kind of go back and realize that, okay, so those changes are going to be necessary. I need to be able to explain what I did. And it was a lot of like going back into my old code and being like, what was I doing here? When I should have done that more consistently as I was going, if that makes sense.
That resonates heavily with me. I mean, I think a lesson I learned, recently, honestly, is one way to avoid that is that if you're just goal oriented on one goal, like the point of messing around with all this data is to do X, you feel like you don't document until you sort of feel like you actually have a roadmap. But the point is, along that process, you often do a lot of other stuff that might be interesting, even though it doesn't seem to you like the goal. Like I transformed this type of file to this, or I learned how to call this language from this language. And just, especially when you're working in like a larger company, often people just ask, wait, how did you do that? And then you were able to show, even though they don't care about your goal, you're able to just show them, actually, this particular thing I did, here's documentation. And that's the thing I figured out, is it's just because there's one goal doesn't mean there's lots of other goals along the way as well. So.
Yeah, that's super relatable. I think even worse, sometimes people would ask me how I got to a certain thing, and not only was it not documented, I had been playing around with so many different ideas that I was just like, I honestly can't remember how I got there. So yeah, definitely something to work on.
Yeah, kind of going off of what you just said with the goal idea is maybe not staying too tunnel visioned on, kind of what the goal was originally. Because I feel like some of our biggest progress in our project wasn't necessarily stuff that in the beginning we really designated was going to be a goal for our project. Like, for example, cutting out the major steps in the pipeline, that kind of came from us trying to primarily implement other different file storage methods that would use less memory. And then along that process, starting to realize as we're implementing it, like, wait, I don't know if this quite makes sense here. Oh, wait, this seems a little bit complicated. What if we started to look in this direction? And starting to question kind of everything that we did along the way, I think allowed us to really cut out some key steps in the process and make the pipeline a lot more efficient. And had we really just, I think kind of keeping an open mind while we were working was a really important part of that.
So just a quick time check for folks. It's 2 minutes before 1:30. So if people are planning to jump to other breakout rooms, now's a good time. Otherwise, we can hang out here for a couple more minutes if anyone else has questions.
I totally agree, Manny.
I just have a kind of a curiosity. I made a flow chart. Was that helpful at all, or of like how the scripts were running and feeding into one another, or was that kind of useless?
I think it was initially helpful. It definitely was not the only, like, it kind of paired with going into the code and actually like it only could do so much. But to understand the general idea of the pipeline, yeah, I would say it was helpful.